On the surface, Uranus looks calm, and yet we have suspected for a long time that inside there must be something very weird going on. So, in 1986, when NASA was finally able to probe Uranus for the first time with its Voyager 2 mission, while most people probably think that Uranus is filled with gas, we are now realizing that it is actually full of something massive. It has taken NASA scientists more than 40 years just to get to the bottom of this bizarre planetary mystery. Today, we go looking for answers deep inside the hidden and fascinating world of Uranus. Now, you may be wondering how Uranus ended up with such a widely misunderstood and often mispronounced name. There is actually a really interesting history there that begins when the planet was first discovered by astronomers.
From here on Earth, Uranus appears to be extremely small, looking like just a dim dot in the night sky.
So, before we really knew anything about it, ancient stargazers actually thought it was a distant and ordinary star. In 1781, however, an amateur astronomer named William Herschel noticed that this dot was moving just a little bit slower than the rest of the stars. It was moving, almost as if it was falling behind the movement of the night sky, catching his immediate attention. Soon enough, the mysterious object was officially classified as the seventh planet in our solar system. He named it in honor of King George III, who was the King of England at that time. Not surprisingly, outside of England, this particular naming decision was not considered very popular or acceptable. So, a few years later, the international scientific community decided to rename the planet to Uranus. Uranus is named after the ancient Greek god of the sky, maintaining a mythological theme for the outer planets. Apart from the Earth, Uranus is the only major planet not named after a Roman god in our solar system. Still, naming it after a Greek deity is a little more consistent than naming it after a British king. Now, at the time, we need to understand that the actual discovery of Uranus was a massive scientific breakthrough. Back then, our existing model of the solar system famously ended with Saturn as the outermost known world. Saturn sits about 1.4 billion kilometers away from the Sun, which was previously thought to be the final frontier.
But Uranus was discovered sitting at just over 3 billion kilometers away from the Sun.
This astonishing distance meant that the known solar system had effectively just doubled in size overnight.
Naturally, astronomers began studying Uranus much more closely, and what they found was truly shocking.
One of the very first things they noticed was that the planet was being orbited by at least 5 major moons. For now, the moons were still far too distant to see any fine details, but something about them was extremely odd. Their orbit around Uranus was nearly vertical, defying the standard rules of planetary mechanics. Since moons typically tend to orbit planets along their equators, this vertical alignment suggested something very weird about Uranus. Unlike most planets, which look like they are spinning roughly upright, Uranus spins in a completely different orientation. Uranus actually looks more as if it is rolling along its orbital path, like a ball. Today, we know that the axis of rotation for Uranus is tilted by about 98 degrees relative to its orbital path. This means the planet is lying almost perfectly on its side, creating a very strange seasonal effect. So, instead of looking at Uranus as just 2 traditional halves, let us break its orbit up into 4 distinct quadrants. In the first quadrant, the planet is rolling perpendicularly relative to the position of the Sun. Because of this orientation, one side of the planet receives constant sunlight, while the other is plunged into complete darkness. Then, as it moves into the next quadrant, the planet is rolling straight head-on toward the Sun. Since Uranus completes a full rotation once every 17 hours, it does actually experience a more Earth-like day-night cycle here. But instead of rising in the east and setting in the west, The sun moves from north to south in a vertical day. In the third quadrant, the side of Uranus that used to be in complete darkness now receives constant daylight. Finally, in the last quadrant, the planet goes back to experiencing a vertical day-night cycle once again. But this time, it happens in the opposite direction, with the sun rising in the south and setting in the north. This bizarre seasonal pattern was completely unlike anything we had ever seen in the solar system before. Scientists initially believed that this odd combination of extreme sun exposure should create fierce weather patterns in the atmosphere. Yet, for some strange reason, whenever we observed it, the planet appeared to be almost entirely still and featureless. This lack of visible weather was very suspicious and meant we needed a closer look to understand the truth. If we wanted to learn what was really going on inside Uranus, we would eventually have to get much closer. However, getting closer was far easier said than done, given the vast distances involved in space exploration. You see, Uranus is nearly 3 billion kilometers away from Earth, making communication and travel extremely difficult. For a very long time, making physical contact with the ice giant was considered nothing but an impossible pipe dream. However, in the mid-1960s, astronomers noticed a rare planetary alignment that only happens once every 175 years. Jupiter, Saturn, Uranus, and Neptune would all line up in a very convenient configuration in their orbital paths. By using each giant planet as a stepping stone in a maneuver known as a gravity assist, a spacecraft could travel far.
A single probe could theoretically visit all 4 outer gas and ice giants in one incredible, historic trip.
It was a highly ambitious concept, but space engineers proved that it was entirely possible to execute. This rare window of opportunity is precisely when NASA officially began planning the legendary Voyager 2 mission. The mission's official launch date was successfully set for the year 1977. However, just a few months before liftoff, researchers discovered something that completely changed how we thought about Uranus. Earlier that year, a group of scientists was observing Uranus as it passed in front of a distant star. During this stellar occultation, something completely unexpected and mysterious happened right before their eyes. Just before moving behind the body of Uranus, the background star flickered a few times in brightness. Then, when it finally came out on the other side of the planet, the star flickered multiple times again. After carefully double-checking all of their measurements, the researchers made a stunning realization. They discovered that Uranus actually possessed faint planetary rings, confirming at least 5 distinct ring structures. But these newly discovered rings around Uranus turned out to be completely abnormal.
Unlike Saturn's magnificent rings, which are broadly spread out and extremely bright, Uranus's rings were dark and thin.
Seeing such unusual rings was very concerning for astrophysicists trying to understand planetary formation.
As a planet spins, you would normally expect all the rocks and dust particles in its rings to scatter widely. Gravity should naturally pull them around in slightly different ways over long periods of time. Over the course of hundreds of millions of years, they should bump into each other and spread into a disk. This exact physical process is a major part of why Saturn's brilliant rings are so wonderfully wide. But in the case of Uranus, the rings were remarkably narrow and stayed neatly confined to specific lanes. Something powerful had to be keeping these stubborn particles in line, but scientists had no idea what it was. Fortunately, with the upcoming launch of Voyager 2, researchers hoped they would finally get some definitive answers.
Voyager 2 successfully launched into the cosmos in the late months of 1977.
After flying past the massive worlds of Jupiter and Saturn, it took nearly 9 long years to finally reach Uranus. The historic spacecraft finally arrived at the distant ice giant in the landmark year of 1986. As the probe closely approached, it discovered that the planet had far more moons than we could see from Earth. Even more fascinating, some of these newly revealed moons looked like they had survived terrible cosmic catastrophes. The icy moon named Miranda, in particular, looked intensely scarred, as if it had been shattered apart. It looked almost as if it had been broken up and hastily Frankensteined back together by a cosmic force. What makes this geological mystery even more surprising is that Miranda is relatively tiny in size. Miranda is only about 470 kilometers in diameter, making it roughly comparable to the size of England. Yet, despite its small size, it boasts some of the steepest cliffs we have ever seen anywhere in our solar system. Some of these staggering cliffs are up to 20 kilometers tall from base to summit. For direct context, the tallest vertical cliff here on Earth is just over 1.6 kilometers high. Aside from discovering 2 more faint rings on the exterior, Voyager 2 also solved the ring confinement mystery. The probe helped us understand why the rings of Uranus remain impossibly narrow instead of spreading out. You see, some of the tiny inner moons of Uranus orbit right alongside the planet's intricate ring systems. As they travel along their paths, their gravity gently pulls and pushes on the nearby ring particles. If tiny particles drift too far inward, one nearby moon gently nudges them back into place. And if those same particles drift too far outward, another moon pulls them back in the opposite direction. Eventually, these balancing gravitational forces create a stable equilibrium that confines the rings tightly. This delicate cosmic dance keeps Uranus's rings confined in remarkably narrow lanes over hundreds of millions of years. This is precisely why these specific bodies are referred to by scientists as shepherd moons. Just like a human shepherd guides a flock of sheep, these moons safely guide the planet's rings. Now, one of the things scientists were most excited to study about Uranus was its mysterious weather patterns. From Earth observations, Uranus had always looked suspiciously bland and devoid of prominent atmospheric features. We knew its upper atmosphere had a substantial amount of methane, which absorbs red light effectively. This abundant methane gives the distant ice giant its distinct and beautiful pale blue-green color. However, we had never actually seen anything interesting or dynamic happening across its smooth face. This lack of activity was extremely odd for a world experiencing such dramatic and prolonged seasonal changes. After all, parts of its atmosphere spend decades in direct sunlight, decades in normal cycles, and decades in dark. So, scientists naturally expected that getting closer would reveal some of the most extreme weather in the solar system. But instead of violent storms or dramatic weather systems, Voyager 2 found a world that was still and calm. As it turns out, a big reason for this atmospheric stillness is because Uranus is missing an internal engine. The planet is missing something crucial that all of its neighboring giant planets possess in abundance. Giant planets like Jupiter, Saturn, and even Neptune all feature highly active and hot planetary cores. These intensely hot interiors constantly release enormous amounts of heat toward their upper atmospheres.
That escaping heat powers massive convection currents, which generate strong winds, storms, and turbulent weather.
But Uranus is dramatically different because it releases almost no extra heat from deep inside. In fact, Uranus radiates almost exactly the same amount of energy that it receives from the distant sun. Unlike the other giant planets, Uranus gives back almost no additional heat beyond the sunlight it absorbs.
This makes Uranus the only giant planet in our solar system that appears to have almost no excess internal heat.
Without that powerful internal heat source, there is far less energy available to drive violent atmospheric circulation. That is one of the main reasons Uranus looks so surprisingly calm compared with the other giant worlds. However, as telescope technology improved, scientists eventually discovered that Uranus was not completely inactive after all.
Sensitive observations revealed small, bright clouds, occasionally appearing high in its atmosphere.
Researchers even detected a handful of surprisingly gentle storms moving through the otherwise calm atmosphere. These discoveries showed that Uranus does experience weather, but on a much quieter and slower scale than scientists once expected. Many of these subtle atmospheric changes appear to be directly connected to Uranus's incredibly long seasonal cycle. Because one season on Uranus lasts for decades, its atmosphere has an extraordinary amount of time to slowly respond to changing sunlight. As sunlight gradually reaches different parts of the planet, new cloud formations can slowly begin to appear. Although far calmer than the other giant planets, Uranus is far from being a completely motionless world. Even today, Uranus remains one of the most peaceful-looking giant planets ever observed. Its unusual behavior reminds us that every giant planet in our solar system has evolved in its own unique way. Every new discovery about Uranus continues to reshape our understanding of how planetary systems can develop. And despite everything we have learned so far, Uranus still holds countless mysteries waiting to be explored. These active cores generate significant amounts of internal heat that acts as vital fuel for local weather. This internal heat is precisely why those other worlds feature prominent, visible storms raging across their surfaces. The core of Uranus is still technically active as well, but it functions at a very minimal level. It does not generate anywhere near as much internal heat as its powerful planetary neighbors do. This means that the atmosphere of Uranus has much less thermal energy to work with overall. So, the great atmospheric mystery appeared to be solved. A cold interior produces a calm, quiet atmosphere. Well, as it turns out, that conclusion was not entirely correct or comprehensive. You see, the unusually inactive core of Uranus actually created a completely different and baffling problem. Before Voyager 2 arrived, scientists did not even know whether Uranus possessed a functional magnetic field. They theorized that it might have one because both Jupiter and Saturn featured strong magnetic environments. But when the probe finally got close enough to measure it, the reality proved completely unexpected. It found that Uranus did indeed have a magnetic field, but it was unlike anything ever seen before. If we look at our own planet Earth, we can see that our magnetic poles align well. Earth's magnetic poles are pretty much in line with its physical axis of rotation. This alignment creates nice, neat, and symmetrical magnetic field lines looping around our home planet. We know that the source of Earth's magnetism comes from deep inside its molten metallic core. There, a solid metal inner core is surrounded by a churning liquid metal outer core. As the liquid metal swirls around the solid center, it acts as a humongous natural electrical generator. This powerful dynamo successfully magnetizes the entire planet and protects our atmosphere from harm. Inside Uranus, however, there is no traditional molten rock and metal ocean driving a standard dynamo. Yet something deep inside the ice giant is generating electricity in the most chaotic way possible.
For starters, the magnetic field of Uranus was not neatly centered inside the body of the planet.
It was heavily offset by around a third of the planet's total radius from the center. Even more strangely, this weird magnetic field was tilted by almost 60 degrees away from its rotation axis. When you remember that the planet's rotation axis was already tilted by 98 degrees, this is wild. This extreme magnetic geometry means that Uranus likely creates some of the strangest space weather anywhere.
Typically, a planet's magnetic field acts a bit like a protective shield against high-energy threats.
The primary thing this invisible magnetic shield guards against is a phenomenon known as solar wind. Our sun constantly creates a lot more than just visible light out into the wider solar system.
It also continuously blasts out massive streams of electrically charged radioactive particles into space.
The planetary magnetic shield normally controls how this harsh solar wind moves around and past the world.
Here on Earth, our stable magnetic field protects us from radiation and creates stunning auroras.
But the magnetic field of Uranus is neither stable nor symmetrical like the one we enjoy.
As the planet spins, its whole magnetic system wobbles through space in a bizarre corkscrew motion. Because of this motion, its auroras do not stay neatly anchored to its geographic poles. Instead, they drift wildly around the entire planet in unpredictable and erratic ways. This strange shape raised an obvious and pressing question for confused astrophysicists studying the data. How could Uranus even have a magnetic field at all if its core was too cold? One leading theory to explain this was that the field was generated closer to the surface.
Voyager 2 helped confirm that Uranus was not simply a colder version of Jupiter or Saturn.
While those worlds are classic gas giants, Uranus belonged to an entirely different category called ice giants. But this is not the kind of ordinary water ice that you would find in your kitchen fridge. Instead, the immense pressure deep inside Uranus transforms these materials into exotic forms unlike anything naturally found on Earth. The deeper we explore Uranus, the more this distant ice giant challenges everything we thought we knew about how planets work.